Alright, so in this particular video, we have a system of 3 boxes that sits on a frictionless horizontal plane here. Alright, here are the masses, 10 kilograms, 14, and 20 from left to right. So part A asks us to find the acceleration of the 3 boxes, part B asks us to find the net force on each box, and then part C asks us to find the contact forces between the boxes. Okay, so let's go ahead and crack this out. Alright, I'll do this using a couple different strategies. Apply whatever it is that makes the most sense to you. Okay, so in order to find the net force, or excuse me, in order to find the acceleration on the 3 boxes, you have to realize that pushing from the left here will cause the system to go to the right, but they all will accelerate at the same rate because they're all pushed and it's one motion. Okay, so that's the first thing you gotta recognize in these types of problems, that they have the same acceleration because they move together. All right. Therefore, I can just set up Newton's second law of sigma fx equals max. Here I've chosen to use the x just to focus on the horizontal direction here. There is no acceleration in the y direction because the boxes are to be in contact with the floor. Alright, so therefore I can just substitute in sigma fx for f, because in this particular diagram the only force acting on the system is just called F. So whatever this particular force is labeled as, here it's labeled as F, so I will just go ahead and replace that with F. M, I just substitute in for M total because I'm pushing from the left side, but really I'm pushing the whole entire system. So therefore this must be M total, and AX here just remains AX. Therefore, I can solve for AX by dividing both sides by M total, just to do the algebra stuff out of the way first. And then from here, we can just plug values in. F is equal to 88 newtons, which is given the diagram here, or in the schematic, or excuse me, in the wording, not the schematic. The schematics is called F, but F in the wording here is 88 newtons. And then the total mass, I just plug here in the denominator. The first mass is 10 kilograms, the second mass is 14, and the third mass is 20. Therefore, if you do that properly, you get 88 divided by 44, and then the acceleration comes out to be 2 meters per second square. But here I've chosen to highlight the plus sign because it asks for acceleration, which is a vector, and according to this diagram, it will accelerate to the right of the screen. Okay, so I will include the plus sign there to include direction. All right. Let's crack out part B. Part B asks us to find the net force on each box. This one is super light work. To find the net force on each box, all you have to do is apply Newton's second law 3 times. Well, there are 3 boxes here, so I would just do it 3 times. But you just have to make sure you use the right M. So here I'll crack it out from left to right. Here is sigma F1, aka mass 1. If I do that for mass 1 on the right side, I must use mass 1. So it's just a plug and chug. M1 is 10. Acceleration is 2. 10 times 2 is 20. Again, here I've chosen to include the plus sign because it has to find net force, and force is a vector. So in this diagram, the acceleration is to the right, so therefore the net force is also to the right, which means that they have to have the same sign. All right. Let's crack out the net force for object 2 in the middle. Therefore, I'm going to do the same procedure again, but here instead of sigma F1, it is now sigma F for M2. M2 is on the right as well, and now it's plug and chug. M2 is 14, acceleration stays the same. 14 times 2 is 28, and then let's do it for mass 3. By now, hopefully you're bored with finding net force. Net force is super easy to find, okay? So we can just do this for the third box on the right side of the screen. Therefore, we'll just use M3, which is 20 kilograms. The acceleration is 2, so therefore the net force is 40 Newton, or positive 40 in this case, if you need the direction. All right. However, in order to find net force, I like to teach my kid this strategy where you do percentages of the mass relative to the total mass. So if you can watch my work, if it makes sense, use it. It's super easy to do. In order to find the net force on any boxes, all you have to do is take that mass and divide it by the total mass and times it by whatever the net force is acting on the system. In this case, this one is pretty straightforward. You only have one force here pointing to the right. So therefore, I will do percentages, okay? I would do M1 over M total because it's going to soak up, it's going to absorb a certain amount of the force that's being applied. So it has to be distributed proportionally to each of these boxes in the diagram. So if you plug in M1, which is 10 divided by 44, which is total mass, and you times that by the net force that's being applied in the system, therefore in this case there's only one force, and that force is pointing to the right, which is 88. So if you do that on your calculator, you get 20. So as you can see, I got 20 over here, and I'm also going to get 20 here. So the net force has to be distributed equally based on mass distribution. Okay, I can do the same skill for M2. M2 here is just 14, M total is 44, the net force on the system is 88. So if I plug those values in, I will also get 28, which is consistent with what I've done here. And therefore, last but not least, just to knock this out using percentages, M3 is 20, M total is 44. So if you do 20 divided by 44 times it by 88, you get 40 newtons. So whichever way you want to do it, doesn't really matter to me, you know, pick one. All right. So therefore, I want to label here. This stuff is going to be important to keep track of in terms of just help you visualizing part C in just a bit here. The net force acting on M1 is 20. The net force acting on M2 is 28. And then the net force acting on M3 is 40. So if you add all this up, it must equal to the net force put in. Well, the net force that was put in is 88 newtons. Okay, so this is how to check to see if you're doing the stuff right. So therefore, when you find the net force on each box, it has to add up to the net force of the system. So 20 plus 28 is 48, and then 48 plus 40 is 88. So I know this stuff is right. And that's one way to check it. All right, let's do part C. I'll do part C a couple of different ways for you. I'll tell you what I prefer, and then I'll do one that's proper. Okay, well, quote unquote proper. In this case, it says to calculate the contact force between the boxes, but it doesn't tell you how, you know, or where to start. So I encourage you, as you look at these systems, I will always start with the box that is farthest from the applied force. So in this case, the applied force is here on the left side. I will work it backward because I know that I can identify all the contact forces, and then the forces, the box on the right side in this diagram, which is farthest from the applied force, has the least amount of forces to deal with. Okay, so watch my arrows that are coming up. It says contact forces, so you need to know that in between these boundaries here, contact between the boxes, there has to be a contact force between these objects. So here I've chosen to draw a vector pointing at this particular surface between M1 and M2, and I would call that force of M1 imparted onto M2. But then Newton's third law says that there's an opposite and equal reaction. Therefore, we have force of 2 onto 1 by placing M2 in front of M1 impedes M1's motion to accelerate faster. So therefore, there is an opposing force here. Okay, and then let's go ahead and knock these other two vectors out. Here, this vector here I would call F2 onto 3. This vector is what's going to cause M3 to move. So I would call that the force exerted by M2 onto M3. However, M3 is in front of M2, which again impedes M2's ability to accelerate. It gets in the way. So therefore, there must be an opposing force exerted by M3 onto M2. So this one we would just call F32. They are equal in magnitude, but they behave differently based on the perspective in which you're in. So for example, if you're looking at M3, what's causing M3 to accelerate to the right? It's F23, because F23 is going to push it to the right. However, if you look at M2's perspective, well, it cannot accelerate as fast because there is this M3 in the way. So M3 is opposing, aka pointing leftward here, relative to M2's movement. Okay. All right. So for this one, it doesn't specify which one to find first, so I'm just going to actually work this one backward. I know that M3 has the least amount of forces touching it. What I mean by that is what's causing M3 to move is this F23, okay? And then if you look at M2, it has like F12 and F32, and if you look at M1, it has an F and then F21. So this one has the least amount of forces touching it, so I will do it from right to left for this diagram. All right, so here I've kind of cropped out the diagram here just to help you visualize. So if you're looking at M3, the question is, we know that M3 is going to accelerate to the right with the rest of the system, but what is causing that M3 to accelerate? It's F23, okay? So it's important that you identify these forces correctly, otherwise your work is going to be messy. The only force that's causing M3 to accelerate to the right is F23, which is what I'm circling, okay? It's the contact force between 2 and 3 that is going to cause M3 to accelerate to the right. So therefore, I can just set up Newton's second law for M3. Here, sigma F3 equals M3AX. Well, what is the net force acting on M3? I only see one arrow, one vector here, and that vector happens to be F2 onto 3. So I just substitute in for net force, which is just one vector here, F23. The mass is M3, AX is just the same. So therefore, I know M3 is 20. I know AX we already found earlier, which is 2. So therefore, I just calculated the force exerted on to M3, which is going to be 40 newtons, okay? But once you find F23, you really have found F32 as well. So here in my statement, I have the magnitude of F23, which is equal to the magnitude of F32. They are the same magnitude, except they behave differently whether they act with you or against you based on the perspective or the box that you're assessing. So therefore, I already found F23, which means that I also found F32, which is 40 newtons. Now, we already know that though, right? I mean, we already know that from doing mass percentages and from doing part A and B. We know that the net force acting on M3 is 40. So you see that there is a consistency here. However, I would not do all this work. I would simply look at it, okay? Here in my box that it's coming up, it says here the net force acting on M3, but I know that M3 has only one force acting on it, which is F23. But we already know from our previous work that the net force on M3 is 40. Well, if there's only one force acting on it, and that is your total, so therefore you can logically think about it. Well, 40 is also your applied force. There's only one force applied, and if your net is 40, therefore that one force is also 40. So I can just simply by deduction know that the net force acting on M3 is 40, therefore the contact force must also be the same magnitude. Okay. Here, now that we're done with F23 in blue and F323 here, so I'm done with this segment here. Let's move on to this F12 and F21. So here, I've cropped out, M3 because I'm done with that. Okay. And then here, I have M3 and 2. So here, even though I have F12 here and F21, I'm going to look at it again backward. So I'm going to combine M2 and M3 here. So here in this diagram, I have M2 and M3. Now what's causing M2 to M3 to accelerate to the right is this particular force here, F12. Okay, so F12 here, this is where the boundary is, but if you look to the right of it, you have M2 and M3. So what I've done is I've just combined M2 and M3 into just one big box. So here I put M2 plus M3, which is 34 kilograms, because 14 plus 20 is 34 kilograms. So really, you just have to learn how to combine these systems so that it just makes your life really easy. So rather than dealing with two boxes, I can just visualize this particular whole right side of the M2 and M3 as just one big box, okay? Therefore, I can make a statement that says F12 is pushing two boxes, which is the sum of 34 kilograms. And I can just set up the physics for that. Here, net force for M2 plus M3 is equal to the mass 2 plus mass 3. But what is causing M2 and M3 to move, if I visualize it as one box, is this force right here, F12, because it's pushing M2 and then M2 pushes M3. So really it's pushing two masses, okay? So therefore, F23 really simplified down to just F12. My total mass here, M2 plus M3, is going to equal to 34 kilograms, and then the acceleration is 2. So therefore, the magnitude of F12 is 68. And once I know F12, I also know F21, which is 68 Newton. So this is just the magnitude. So on quizzes and stuff like that, on assessment, just be careful with whether you put a plus or a negative based on which force is being asked of you. All right, which makes sense. So 68 makes sense because, ready? Earlier we found that the net force on M2 was 28. We also found the net force on M3 is 40. So therefore, 28 plus 40 is 68. So in order to get these two boxes to move at a rate of 2 meters per second square, you need to put in 68 newtons, which makes sense, okay? Now, okay, so there you go. If you look at it, if you look at M2 and M3 just as one big box, the net force act on it is 68. All right. Or you can do percentages again. You can look at this. If you look at M2 and M3 together, that makes up 34 kilograms, but the total mass is 44. So I can do the mass of M2 plus M3 divided by the total mass and then times it by the total force. M2 and M3 is 34 kilogram divided by the total mass, which is 44, and then times that by 88 because that's how much force is acting on the system. Okay, so therefore, I can just go ahead and make a conclusion that it comes out to be 68 as well. All right, so that's that. Now, the other way to do it is going from left to right. So in my previous strategy, I went from right to left, but let's just assume that you don't know how to look at this stuff and you just want to make it difficult. You can go from left to right. Okay. If you go from left to right, you'd have to do M1 first. But then to do M1 first, you have an F3 that's pushing rightward, and then you have F21 acting against it. So putting M2 in front of M1 again slows it down. So I need to pick this vector here that's pointing leftward because impeding would imply opposing. Opposing would imply the opposite vector. So you got a vector pointing right. You do not want to use F12, right? You want to use F21 because it's opposing M1's motion. So if I set up Newton's second law for M1, I have F minus F21 because F is to the right, F21 is pointing left, so I'll subtract that. Again, here I've already accounted for the negative sign. Therefore, to solve for F21, just do a little algebra manipulation. Move negative F21 to the right side, which makes it positive. Move M1 AX to the left side, which makes it minus. So here I have 88, which is F minus M1, which is 10, acceleration is 2. So if you do this correctly, 88 minus 20, which is 68. As you can see, the answer is the same as the previous strategy. So instead of going from right to left for this one, I will go from left to right. It doesn't really matter. As long as you set up your physics right, you should get the same answer. Here, let's look at M2. Okay, so if you're going to go from left to right, I'm done with M1. The next mass would be M2. But to find M2, what is causing M2 to move is F12, which is pointing rightward. Well, having a box M3 in front of it, again, gets in the way. So I'm going to choose the F32, which is pointing leftward. So in my work here for M2, I have F12 that's pushing it to the right, aka contact force. But then there's another contact force from M3 that's slowing it down. So I'm going to take F12 minus F32, and that equals M28X. And all you have to do is plug in values here, do a little algebra stuff. Again, if you're going to solve for F32, I say for it, move it to the right side, which makes it F32 or positive. And then the negative here comes from just moving M2A on the left side. So as you move stuff, make sure you change signs. F12 we just found is 68. M2 is 14, A is 2. So therefore, we can just simplify this down real quick. 68 minus 28, and that'll give us a difference of 40. Okay, so therefore, once we know F32, once we know F23, so we can just find these values quickly from left to right as well. So whichever strategy you employ, that's up to you, but it should work out the same. All right, stay nerdy. Okay, don't be whack.